Okay, so have you ever tried to like make a portrait but out of coffee grounds?
I can't say that I have.
It's kind of like what these researchers are trying to do, but with like brainwaves and images. Welcome to Talk Tensors, everyone, the podcast that takes like, those super head-scratching academic papers and turns them into something you can actually like wrap your neurons around.
Yeah,
So
I bet that.
we're diving into,
Yeah.
guess what I think? Streamlined EEG-to-Image generation with latent diffusion models.
Definitely a catchy title. I'll give them that.
Yeah, it does make you kind of wonder, like, they're seriously trying to generate images just from electrical signals in, like, your brain using EEG,
Yeah.
which, by the way, is way more chill than being stuck in one of those fMRI machines.
Oh, for sure.
Imagine what this could, like, mean for, understanding how we process visual information or even helping people who can't communicate verbally.
Yeah.
They could express themselves through images.
Definitely a huge what if moment for, science. The core problem that the paper tackles is that EEG data is notoriously noisy.
Right.
And it's tough to get, like, precise location information from it. It's like, how blurry photo loses all the detail? That's kind of the challenge with EEG compared to, say, an fMRI scan.
So how do they even go from fuzzy brainwaves to, like, a clear picture?
Well, that's where GWIT comes in, their proposed framework.
Yeah?
They're taking these like really powerful AI image generators like Stable Diffusion, you might have heard of it, and basically giving them an EEG signal as an input. Think of it like this. You like whisper a concept in the ear of an artist,
Okay.
and they sketch it out based on that whisper. The whisper is the EEG, and the artist is the AI model.
But isn't there still a lot of interpretation involved? Like, if I say cat, the artist could draw a million different cats.
Yeah, for sure.
Yeah.
That's where the control net part comes in.
Okay.
It's a neural network structure that acts like a filter, refining those initial messy signals from the EEG into something that the image generator can understand.
So I'm picturing like one of those old HA sketches, and control net is like the knob, carefully guiding the lines to create a recognizable image.
Yeah, I like that analogy. The paper actually has a diagram that might help, visualize this whole process. Figure 1, take a look. You've got the EEG data being processed and then mixed with a noisy image in something called latent space. Just think of it as a mathematical playground where images are just numbers.
Okay, so we've got this jumble of numbers representing the image. What happens next?
Well, there's a second AI model trained specifically to decode images from EEG data.
Uh-huh.
And that gives the generator, a nudge in the right direction. It gives it a simple caption, like image of a mountain,
Oh, so like giving the artist a rough outline before they start shading and everything.
Precisely. Then ControlNet takes over, using the specific patterns in the EEG data to shape the image as it emerges from all that noise.
So how do we know if this whole control net and whispering to like AI artists thing actually works?
Well, they put GWIT head-to-head with some of the other, leading models out there. And the results were, really pretty convincing.
Yeah.
Not only did they generate, like, higher quality images, but the images actually reflected what people were thinking about, which is, the whole point, right? Take a look at figures 2, 3, and 4 in the paper. You can really see the difference. They used metrics like FID, IS, and a particularly important one called ACC to measure how well the generated image matched the, intended object. And GWIT just nailed it.
So it's not just about making pretty pictures. It's about capturing like the essence of what's going on in that brain of yours.
Exactly.
They didn't just stop there though, right?
Right.
They did some of those like fancy ablation studies to really see what makes GWAT tick.
Right. Essentially, they took GWIT apart piece by piece, like a Lego set.
Mhm.
They wanted to know if each component was really doing its job.
Okay.
For example, they removed the control net part. And surprise, surprise, the images went downhill fast. So that proved that the brainwave guidance is really the key here.
Okay, so control net is like mission critical. What else did they tinker with?
Well, they played around with different modes, what they call drop and guess. These basically fine-tune how much GWIT relies on the EEG data versus that initial caption we talked about.
Okay.
And those modes can actually enhance how closely the generated image reflects the thought. It's all about getting the recipe just right.
So they've got this framework that takes brain signals, feeds them to an AI image generator with control net steering the wheel, and voila, we're generating images from thoughts. But like, where does this all lead? What's next? That's what we're going to dive into right after this.
It's easy to get caught up in the whole wow factor of turning brainwaves into images, but
Yeah.
this research didn't just appear out of nowhere.
Right. It's like, where did this whole idea even come from? Was it a bunch of scientists binge watching sci-fi movies and just being like, we can do that?
Maybe. But really, it's been a long road building on decades of work in neuroscience, signal processing, and good old-fashioned AI. Those early attempts at decoding visual information from, brain activity were pretty limited, though.
Yeah.
The technology just wasn't there yet.
So back in the day, before we had these super-powered AI models, how did they even approach this?
Researchers mainly relied on simpler techniques like linear models and basic neural networks. They could pick up on, some rudimentary patterns in the brain signals.
Yeah.
But generating a realistic image, not so much. It's kind of like comparing those old school pixelated video game graphics to the stunningly realistic stuff we have today.
Yeah, you wouldn't exactly call Pac-Man a visual masterpiece.
Exactly. Then came, the deep learning revolution and things really started to take off. Generative adversarial networks, or GANs, became the hot new thing. They basically pit two neural networks against each other, in kind of an AI battle royale. One tries to create realistic images, the other tries to spot the fakes. This competition forces both networks to, become better and better over time.
So it's like they're constantly trying to outsmart each other.
Precisely. That led to some big leaps forward in image quality.
Okay.
But GANs could be, really tricky to train, and sometimes the results were, they were a bit wonky.
Wonky. Okay. Then along came these diffusion models, which seem to be all the rage these days. How are they different?
Diffusion models are the masters of controlled chaos. Imagine taking a pristine photo and slowly adding more and more static until it's just pure noise.
Right.
Then you train a neural network to reverse this process, essentially teaching it to go from noise to a clear image.
It's like taking a puzzle apart and then training a computer to put it back together without even seeing the original picture.
Yeah, that's a great way to put it. And it's proven to be incredibly powerful, generating those, hyper-realistic images we've all been so impressed by.
So how does GWIT fit into this whole evolution of image generation? Is it just riding the diffusion model wave?
Well, it's definitely riding the wave using stable diffusion, one of the most advanced diffusion models out there.
Okay.
But the real genius is in how it incorporates, EEG signals. Remember, control net, that's the bridge between the brainwaves and the diffusion model.
So it's taking the best of both worlds, the stunning image quality of diffusion models.
All right.
And the ability to actually listen to what the brain is saying.
Exactly.
It's pretty mind-blowing to think that we've come this far from those early blurry attempts to now, where we can generate recognizable images from brain activity in real time.
Yeah, it's crazy, right?
Makes you wonder, what's next? Right?
That is the big question, isn't it? Where do we go from here?
Well, before we get too carried away with predicting the future, let's talk about what this technology could actually do in the real world.
Yeah.
Now, we've hinted at some applications, but, I think it's worth digging a little deeper.
I agree. The potential applications are vast and could really impact, a whole range of fields.
Let's start with, the obvious one, healthcare.
Right.
Imagine using this technology to, diagnose and treat neurological disorders.
Uh-huh.
It could be life-changing for people who have lost the ability to communicate verbally.
Yeah.
They could finally express their thoughts and needs through images.
Precisely. And for individuals with conditions like locked-in syndrome, this technology could provide, a way to interact with the world around them, which is incredible to think about.
It's like giving them a voice they never thought they'd have.
Yeah.
And think about the possibilities for rehabilitation.
Yeah.
Some stroke patients, for example, could use this to retrain their brains and regain lost motor function.
It could even revolutionize how we study the brain itself. We could use this technology to track the effects of different therapies and medications on brain activity in a way that's, never been possible before.
Right.
The possibilities in healthcare are truly exciting.
And it's not just limited to medicine, right?
Right.
Imagine the potential for education.
Oh, yeah.
We could create personalized learning experiences tailored to each student's unique brain activity.
Yeah.
Imagine a world where education is truly individualized, where every student gets exactly what they need to succeed.
That's a powerful vision. And we could even use this technology to identify learning disabilities early on, providing targeted interventions and support to help students overcome those challenges.
Yeah.
It could be a game changer for education.
And let's not forget about the, creative fields, art and design.
Oh, for sure.
Imagine artists using this technology to create like works of art directly from their imaginations, bypassing the limitations of, traditional tools and techniques.
It would be like painting with your mind. Yeah.
Designers could use it to visualize and refine their concepts in real time, seeing how different ideas translate into, visual representations. We could even create entirely new forms of entertainment, like immersive experiences that blur the lines between, reality and imagination.
The potential really is limitless.
Yeah.
It's like we're on the cusp of like a whole new era of creativity and innovation.
It's really cool.
But of course, with any powerful technology, there are always, ethical considerations to keep in mind.
Yeah, for sure.
We have to be mindful of the potential for misuse and ensure that like this technology is used responsibly.
Absolutely.
Yeah.
You're absolutely right. Privacy is a major concern. Imagine if someone could access your thoughts and visualize your most private memories or fantasies, without your consent. That's a scenario we want to avoid.
Definitely.
Yeah.
We need to have open and honest conversations about these potential, risks and benefits and establish clear guidelines and regulations to ensure that this technology is used ethically.
Right. It's about finding that balance between, progress and responsibility.
Well said. It's crucial that we approach this technology with both excitement and caution, recognizing its immense potential while also, safeguarding against potential harm.
All right, so we've talked about the technical details, the history, the potential applications, and the ethical considerations. I think it's time to let loose a little and have some fun with this. Are you ready for some, novel notions?
Oh, yes. I always love this part. Let's get those creative juices flowing.
Okay, so we've already established that turning brainwaves into pictures is pretty wild.
Right.
But let's crank up the what if dial even further.
Yeah.
We talked about generating videos from brain activity, but what if we went, beyond just watching those thoughts?
Yeah.
What if we could create a whole interactive virtual world, stepping into a dream where everything reacts to what you're thinking and feeling?
Now, you're talking about a true brain-computer interface where, our minds are directly linked to a digital reality. It's a pretty trippy concept.
Right. Imagine thinking of a landscape and boom, it just materializes around you.
Mm.
Or picturing a character and suddenly they're right there, chatting with you, reacting to your emotions.
Uh-huh.
It's like having the ultimate creative control.
It would be fascinating to see how this kind of technology could change the way we approach things like therapy or education, even entertainment.
Right.
Imagine treating phobias by gradually exposing someone to their fears in a virtual world that feels, totally real but is completely safe.
Or using these virtual environments to train surgeons or pilots, letting them practice complex procedures without any real world consequences.
Right.
The possibilities are mind-boggling.
And think about the implications for education. What if we could tailor, lessons to a student's individual brain activity, making learning truly engaging and effective? It could revolutionize the way we, teach and learn.
Okay, but here's where things get really wild.
Yeah.
What if we could connect multiple minds to the same virtual world, creating a shared experience where everyone's thoughts and emotions are shaping the reality around them?
Whoa. Now you're talking about a whole new level of social interaction.
Right.
Imagine collaborating on creative projects in real time, seeing your ideas, merge and evolve as you interact with others, or using it to, bridge cultural divides, allowing people to literally step into each other's shoes and experience the world from a different perspective.
It's almost like a telepathic internet where we can connect and understand each other on a deeper level than ever before.
Yeah.
But of course, there's some big ethical questions we need to wrestle with before we start, plugging our brains into a shared virtual world.
Absolutely. We need to make sure, this technology is used responsibly and that people's privacy and autonomy are protected.
Right.
Imagine the potential for manipulation or exploitation if someone could, access and influence your thoughts and emotions in a shared virtual space.
Yeah.
It's a powerful technology, and with great power comes great responsibility.
That's a really good point.
Yeah.
It's crucial that we have these conversations now before this technology becomes, widely available.
Right.
We need to figure out how to, safeguard against potential harms while still allowing for the, incredible possibilities it offers.
Well, as we've seen with this whole, EEG to image generation thing, sometimes reality catches up to science fiction faster than we expect. Who knows what amazing breakthroughs are just around the corner?
It's an exciting time to be following the world of AI and neuroscience, that's for sure. All right, listeners, we've taken you on a journey from brainwaves to pictures, from the history of the field to some, wild hypothetical scenarios. We hope you've enjoyed this deep dive into Guess What I Think. Remember, you can find a link to the paper in the show notes.
And if you're eager for more thought-provoking discussions about, cutting-edge research, be sure to subscribe to Talk Tensors and join us next time for another adventure in the world of machine learning.
Until then, keep those brainwaves firing and let us know what, novel notions this episode sparked for you. We'd love to hear your thoughts.